Good morning, afternoon, and evening to all of you from wherever you are joining us today. Before we start today's session, please feel free to do event check-in. This will give you access to additional resources and information about events that we are running on Reactor, which are around similar topics to today's session. Also, you will be able to access links from today's session. I will share the event check-in link with the event ID in the Q&A section shortly. Also, we have launched our Reactor group on LinkedIn. Please feel free to join the group to get the latest update on session happening on Reactor. I will share the joining link soon. Thank you all once again for joining us today. My name is Rashmita and I'm the event planner for Microsoft Reactor Bengaluru, India. The session will run over the next 60 minutes including Q&A. The session is being recorded and will be uploaded to our Reactor YouTube channel within 3 to 4 days. I will share the link to our YouTube channel in the chat section soon. Also, please keep your mics muted during the session. Quick word on our code of conduct. We display this at all Microsoft Reactor events that we run, and it's just a reminder to be aware of others. Key thing to take out here is to be respectful of other people's views, understanding of differences, being kind and considerate in the way you engage. The chat will be open throughout, and we do encourage you all to participate. I would now like to welcome Mithun, our speaker for today's session. Mithun describes himself to be a jack of all trades, splitting his time between writing code and wearing other hats for his startup. Currently working as CEO in Skewed Ventures, but for now, I will hand over to Mithun to begin the session. Over to you.
Hi everyone, can you hear me?
Yes, Mithun.
Perfect, thank you. Hi everyone, welcome to today's session. So today we'll be talking about high availability and resiliency in your applications that are hosted on Azure. So I do want this to be a little bit of an interactive session. So although we may not have audio from the audience, please feel free at any point in time, whenever you have any questions, please feel free to type them in the chat window. So I'll be looking at it from time to time. We'll definitely have a 10-15 minute Q&A session towards the end. But at any point in time, do not hesitate to post your questions in the chat window. And with that said, let us get started. All right, so let me begin by sharing my screen. All right. So we do have a couple of demos as well as slides. So hopefully, we'll fill up the hour. All right, so first and foremost, I am on Twitter. This is my handle. I also have a blog that I try to maintain semi-regularly. So feel free to connect with me on Twitter. That's my Twitter handle. All right. So when we talk about Azure global infrastructure, right? So there are a bunch of terms that are thrown around. Geographies, availability zones, regions, data centers, availability sets. So how do we make sense of all this? Like, what is the taxonomy, right? What's the top level component? Does a zone contain a region? Does a region contain a zone? So there's a whole lot of terms that are in use, but we don't necessarily have clarity around how they are organized in an hierarchy. So let's look at that. So at a high level, the entire Azure global infrastructure is broken down into geographies, right? So if you can see the slide here, so you have geography. So roughly you can think of a geography as a country. Previously, there used to be just 4 geographies, Americas, Europe, Asia, Pacific, and Middle East. But now they have redefined a geography to be a country. So for example, India is a geography with 3 regions in it: South India, Central India, and West India. So similarly, US is a geography with, I think, 7 odd regions inside it. So good place to actually look up those details is, and I'm going to put up the links in the notes later on. But Azure has this documentation page, and you can actually look up the list of geographies. So geography is the highest level component, if you will, in the hierarchy. So as you can see, it roughly maps to a country, right? Sometimes to a continent, but roughly to a country. So just for the sake of this example, let me select USA as my geography. So it'll show a breakdown of all the regions inside that geography. So geography is important, especially when you're meeting compliance requirements. So if you, by regulation, you're required to have all your data within a geography or within a country, at that point, the concept of a geography becomes very important. So that's the highest level component, right? The highest level in the hierarchy, geography. Now, within geography, we have multiple regions in which data centers are actually deployed. But before we actually get into region, we have to talk about regional pairs. So, for example, the US geography might have 7 or 8 regions, but they are actually sort of clubbed together in pairs. So what are pairs? So pairs are nothing but, you can loosely think of them as a primary and a secondary. So there's actually a good document which Azure Regional about that. Okay. So high level, all of your regions are paired together. So your region, any region that you select belongs to a pair. So for example, in North America, East US and West US are paired together. And for example, in UK West and UK South are paired together. So the concept of a pair is sort of important. Let's say during a maintenance schedule, they don't upgrade resources in simultaneously across a pair. So they upgrade one region in a pair, and then they bring up the maintain or rather update the other region in the pair. So they don't do it simultaneously. So this ensures that you have at least one redundancy that is up and running and available at all times. Also, if there is a geographical level outage, they will ensure that at least one region in a pair is brought up as a matter of priority. So from that perspective, it is always helpful to think of your primaries and secondaries, and you should probably provision your primaries and secondaries across regional pairs. All right, back to our presentation. So geographies, regional pairs, regions. Okay. So multiple regions within a geography, 60 plus regions globally. So it used to be some 50 plus. Now I think I've lost count. I think there are some 60 odd regions in which Azure resources are available. Like I said, it's regions are sort of clubbed together in regional pairs. And within a region, you have multiple data centers. Okay, so we'll talk about availability zones in a second, but think of a region as having multiple data centers. So again, the taxonomy goes something like this. So there is a one-to-many relationship between geographies and region. A geography will contain multiple regions. Those regions will obviously be organized in pairs. Similarly, a region will contain multiple data centers. So there is a one-to-many relationship there. And the data centers will be clustered in availability zones. So think of a region as having some regions will have 3 or more availability zones. Some regions may not have any availability zones. So, but at a high level, a region will contain multiple data centers. Okay, like I said, some regions have availability zones. Like for example, East US 2 or West US, they have availability zones. But something like I believe like West India does not have an availability zone. I might be wrong there, but all right. And inside availability zones, we have this concept of fault domains. Sorry, inside data centers, we have this concept of fault domains, update domains, and availability set. And we'll look at that in further slides. Again, this is a taxonomy or the hierarchy rather. Geographies and regions arranged in regional pairs. And inside a region, you have multiple data centers, and data centers are clubbed together in availability zones. So all of this is critical when you have to understand the SLA or the service level agreement, or rather, it's just a fancy word for saying uptime of your application. So you have to, if you want to plan for the uptime of your application, you have to put a redundancy in across each zone or across each set or across multiple regions in a geography. And we'll get to that in a second. All right, so regional pairs, like we saw, this is the list of regional pairs. So every region is clubbed with some other region. So for example, if your compliance requirements state that your apps, your data or your application must reside within one specific geography like USA, then you have to plan for both your primary and secondary residing within that geography. But you can actually have your primary and secondary be a part of a regional pair. So that way, when you have a geographical level outage, at least one of them will be prioritized and brought back up. And during a maintenance schedule, you're always guaranteed that both of them are not going to be updated at the same time. Only one of them will maybe down for update. So the other redundancy is still available. So yeah, during planned platform maintenance, only one region is updated at a time. And in case of a geographical or multi-regional outage, they will prioritize one region in a pair to be brought up for recovery. So that's the high-level concept of a regional pair. Now let's look at region. So data centers, like I said, there is a one-to-many relationship between a region and a data center. So data center contains multiple regions. So data centers within a region are connected by a low latency network. Multiple data centers within a region, and some regions which support availability zones. In those cases, the data centers are clustered together in availability zones. So think of it this way. Let me bring up my notepad here just to make this thing clear. I have a region. The region supports availability zones. So you will have availability zone 1, availability zone 2, maybe 3, and maybe more sometimes. But if it supports an availability zone, then you are guaranteed to have at least 3 availability zones. And inside an availability zones, you will have data centers. Multiple of them. Okay. So that's the high level. For some reason, your region doesn't support data, the region doesn't support availability zones, then it gets a little flattened and it'll look something like this. Right. So you directly have data centers within the region. All right. Okay. So let's look at availability zones in a bit of detail. Again, this is for building up, ensuring that you have redundancies across a region, or rather redundancies within a region. So you essentially, let's say you have a virtual machine. Now you can put that virtual machine, you can create 3 redundant copies of that virtual machine and put each VM in a availability zone. So even if so now you have 3 redundancies. You generally use a load balancer to direct traffic between those 3. And let's say one region gets knocked out because of some outage. The other 2 redundancies are always available there. So this is just a way of ensuring that you have a higher SLA if you need to increase it from, let's say, 99.95 to 99.99, you would have to create redundancies across availability zones. And even Azure's documentation, if you look up the SLA documentation, Azure SLA, if you look up the documentation for virtual machines, they do not offer any SLA or any SLA guarantees unless the machines are in availability zones. So if it is in availability zone, you have a 99.99% SLA. If you are in availability set, and we'll talk about sets later, you have a 99.95% SLA. But Azure doesn't provide any uptime guarantees for a single virtual machine. But if you have at least one instance across, if you have two or more instances separated by availability zones, then you have a 99% SLA. All right. And what we mean by SLA, if that term is not familiar, there's actually a nice document for that as well. I think it's in. The link is. I forget where the. I think it's somewhere in the Azure Architecture Center. If I search here for SLA. All right, I'll put up those links in the notes later. But yeah, with SLA, essentially, you want to see more number of nines. So higher the number of nines in that SLA, what we call as a 4 nines is a couple of minutes of downtime. 5 nines is a couple of seconds of downtime per year. So you want to see a high number of nines in that number. All right, and essentially by creating multiple instances and using a load balancer in front of it, you are essentially increasing the resiliency of your application because you have one instance up and running at all times. So your number of nines goes up. All right, so availability zones again offers redundancy at a regional level. So your region is broken down into zones, and you're going to place your virtual machine or your application server across availability zones there. So Azure resources themselves are classified as zone redundant, which means there is a copy in each zone. There is zonal or zone specific, which means there can only be one copy in each zone, or non-zonal, which means it doesn't work with availability zones. So availability zones themselves are free. There is no cost to it. You are only paying for the resources that you put in availability zones, like a virtual machine or application app service or something like that. Zonal VMs need not be identical. So remember that you are creating this redundancy so that you can serve traffic, right? So even if you can serve a minimum amount of traffic, that's fine. You are guaranteeing some uptime. It's ideal to have all your zonal VMs be identical in nature, but it's not fully necessary. So your primary can be, a 5 or rather 8 core machine, and your secondary can be a 2-core machine. So as long as it serves out some traffic, you'll be fine. Again, only specific regions support availability zones. Not all regions have a zonal support. So the list of which region has what resources, you can look up here. So let's say you can see zone support. So for example, you can see that Central US has 3 availability zones, but East US 3, it's coming soon, so it doesn't have anything. North Central US doesn't have any availability zone. So the nearest region which has availability zone is Central US. So if you're planning a highly available application, then given that there is no availability zone support in this region, you might want to put it in some other location like Central US. So this is critical for your planning. So before you lay out your design, just make sure you walk through this and see which ones have support and which ones don't. So the Azure resources that support availability zones, VMs. So VMs are zone agnostic, which means you have to put one instance in each zone. Same with VM scale sets. Zone redundant storage accounts, and we'll get into this, we'll see this in detail, but zone redundant storage account ensures that you have a copy of your data in each of the 3 availability zones. So this is a zone redundant, while VMs are zone specific. Managed disk, again, if you combine them with availability zones, you can ensure that you have one copy in each zone. Same for public IP. In the standard SKU of public IPs, you can have zone agnostic or zone redundant public IPs. So even if one zone goes down, that public IP still remains accessible. Load balancers, by design, they have to be zone redundant. So the whole purpose of a load balancer is, when a zone goes down, you have to ensure that the load balancer, at least the load balancer keeps working. So you have to pair a load balancer with a standard public IP SKU. And then you have other resources like VPN gateways, SQL, and we will look at all of these in detail in further slides. So important thing to note is zonal resources, once they are created, cannot be moved to other availability zones. So this is a decision that you have to take during the resource creation. So at the time of creating the resource, you decide which zone you want to put it in. Okay. So let's actually look at an example here. So I'm going to go over to my Azure portal, and maybe I'm just going to go create a virtual machine here. Okay. So we're going to give it a VM demo. And here in the availability options, okay, you have to select whether you want to put it in an availability zone or an availability set. And we'll get to availability sets in a little bit, but right now let's, if we don't select anything, then we don't have any redundancy built in. So we select an availability zone, and then we have to select, hey, which of these 3 availability zones do I want to put it in? So VM1 can probably go into availability zone 1. And similarly, VM2 can go into availability zone 2, and VM3 can go in zone 3. So now I have 3 redundancies split across availability zones. And then obviously I'll have to pair that with a load balancer, so to direct traffic to one of these 3 backend machines. So I already have a pre-created instance. So let me jump into that directly. So in our load balancer demo, so this is a demo of availability zones. So I have 2 virtual machines. Both of these virtual machines have Nginx server running on it. So I'm gonna just do a quick check here. So this one has a public IP address. Now you can see that this machine is in zone 1. Okay. So VM1 is in zone 1, and here is the IP address. Right, it says welcome to VM1. And similarly, VM2 is in zone 2. Here in zone 2, same region, East US. And it has a different IP address. So I'm just going to paste that. Oops. Yeah, welcome to VM2. Okay, so this is VM1 and this is VM2. Both of them have public IP addresses, and both of them are in different zones. And on the thing that actually directs traffic to them is this entity called the load balancer. So we put a load balancer in front of it. So load balancer essentially has its own IP address. So, and this is a zone redundant IP address, which means even if one or two zone goes down, this IP address will still continue to be available. So, and then it is associated with a backend pool. So virtual machine 1 and virtual machine 2, which are in zone 1 and zone 2 respectively, they are put in the same backend pool. So the job of the load balancer is to ensure that there is at least one redundancy or one instance in this pool that is serving traffic. Okay, and its job is to direct you to one of those instances. And then there are health probes. So health probe is nothing that, something that the load balancer uses to check whether an instance is up and running and healthy. So in this example, we send traffic, the load balancer sends traffic on port 80 TCP traffic. And if it doesn't receive responses twice in a row, so it sends it every 5 seconds, it pings port 80. And if it doesn't receive any responses 2 times in a row, it considers that backend instance to be unhealthy and it doesn't direct traffic anymore. So let's look at that. And then there are like load balancing rules, which sort of ties everything together. So this is a rule which ties the front end configuration to the back end configuration with the health probe. Okay. So let's take a look at this in action. So now the load balancer has its own IP address. So I'm going to copy that. So it has to direct me either to VM1 or to VM2. So it's directing me to VM2, and this can vary. Now it's directing me to VM1. So there is no session stickiness or session persistence. So whichever instance is available to serve traffic, you can serve it. So actually you can try it out. This is the IP address. So 52.146.66.224. You can try it out for yourself, and you'll either see VM1 or VM2 in your on your browser. Okay, give it a try. 52.146.66.224. And let me know in the chat window whether you're hitting VM1 or VM2. All right. Okay. So now what we'll do is, so this one is serving VM1. So let's go ahead and turn off, this is so it's serving me from VM1. So I'm going to turn off VM1 and then we'll see that it will only serve me from VM2. So I'm going to turn off VM1 and say stop. All right, so from the chat window, it looks like people are hitting a mix of VM1 and VM2s. Somebody said VM3, which is not possible because I don't have a VM3 there in the backend pool. All right, so I've turned off VM1 and it is turning off. Okay, let's give it a couple of seconds. I think that should be enough. Now we can hit the load balancer again, and this should change to VM2 because VM1 is no longer serving traffic, and that is determined by this health probe. So if I come to VM1, just VM1, and hit it. Wait a second. I think I've got the IPs mixed up here. 1 second. So VM1, which was turned off, this was the IP address. So now if I hit it, I think I have some disabled cache. That's bizarre. So VM1 is now turned off. VM2, it's still showing me cached data. So VM2 and let's go to VM3. Sorry, the load balancer here. So you'll see that now it has switched over from VM1 to VM2. So that way it is guaranteeing that at least one instance is up and running at all points. All right. Portal. Back to our slides. All right. So that's how the availability zone thing works with load balancers. And we'll look at load balancers in a little detail in the next few slides. All right, so back to our hierarchy. If we remember again, we looked at geographies, regional pairs, regions, availability zones, and data centers within availability zones. Now, let us look at stuff that happens within a data center. Okay, so if I just want to put my resources within a data center. I want to restrict the placement to one data center. How can I guarantee redundancies? And that is generally done with this concept called availability set. So let's look at that. Okay, so data center, as everyone is probably familiar, it's rows and rows of rack mount machines. So each of these is called as a rack mount, and they have servers on these rack mount. Okay, so and you have rows of these servers. So so these physical racks, right? Multiple physical racks within a data center. Okay, so this vertical thing is a physical rack, and you have multiple of these. So there are multiple servers in the physical rack, but every rack shares the same network switch and the power supply. Okay, so that means there is a common fault domain that all the machines or the servers on that physical rack have. So since they have a common power supply and common network switch, if the network switch goes out or the power supply goes out, that means all machines go offline here. So they are all residing in the same fault domain, right? That one single point of hardware failure sort of combines all these machines together. And so that is known as the fault domain, right? The single point of hardware failure. Then there is also a logical grouping of machines which ensures that those machines are updated or upgraded or maintained. The maintenance upgrade happens at the same time. So you can roughly think of it like, every machine in row 4 will get updated at the same time. So that row 4 then becomes known as an update domain, which means if you are lying in row 4 across any of these, then you're essentially going to get updated at the same time. So that sort of becomes a point of failure. Like if there is an update window, then all the machine number 4 in that physical rack will be updated at the same time. So the goal here is to ensure that if you are planning for redundancies in an availability set, make sure that your redundant copies of your machines do not lie in the same fault domain and same update domain. So what do we mean by that? So again, from the previous slide, we have visualized that the fault domain, that's the vertical thing. All the machines, physical machines in that rack, share the single point of hardware failure. So they are lying in the same fault domain, while on this row, they are lying in the same update domain. Okay, so you can visualize it like this. So now if you want to plan for redundancies, let's say you are planning for 3 virtual machines. So you have to place virtual machine 1 in fault domain 0 and update domain 0. And if you're bringing in a second redundancy, you have to ensure that it doesn't have a common fault domain or update domain with the previous virtual machine. So this is to ensure that, let's say this fault domain goes down. So it's going to take down all the VMs that are in the fault domain. If this update domain decides to there's an upgrade cycle, then it's going to take out all the machines offline. So if you have redundancies, ensure that they don't share a common fault domain and update domain. So the way this placement happens is, again, back when you go back to creating a virtual machine. So let's say you want to create a virtual machine and you want to choose availability sets this time. So let's put it in here and I'll call it demo VM1. And I'm going to select availability set. Now remember, availability zone is when you want to spread your redundancies across multiple zones in a region. And here it is, you want to spread it across different fault and update domains within the same data center. So this is why when you are splitting your redundancies across availability sets, it will have a lower SLA. Then so all it takes is like if the entire data center gets knocked offline, then essentially all 3 copies are unavailable. Or all redundancies are unavailable. Remember that this is going to give you again from the SLA docs. If you spread the redundancies across availability set, it has a 99.95% uptime guarantee, while here it has 99.99 in availability zones. So the higher up the hierarchy you move, right, higher up the hierarchy, the better your SLA will be, because it's easy for a data center outage to happen. So when that happens, all the storage clusters and compute clusters get taken offline. But it's harder for all availability zones in a region to be offline at the same time. So this is why you have higher SLA. If you even split your resources across different regions in a geography or across different geographies, then you have even higher SLA, right? So then it goes into 4 nines or 5 nines, or in case of SQL Server up to 7 nines also. So those things are also possible. All right. So let's look at an example of a availability set. So I'm going to see. So the difference between availability set and availability zone is, in an availability zone, you pick the placement. So there are 3 zones by default, you pick one of them. But in an availability set, you have to create the set. So let's create a set. And here it asks you, hey, do you want, how many fault and update domains do you want? Okay. So if I choose 2 fault domains and 5 update domains, now this is essentially a 5x2 grid, which means I can put up to 10 redundancies there. Okay. So you get to select depending upon number of redundancies that you want. So if you don't want them updated at the same time, maybe want to increase the number of update domains, that's completely possible. Again, there is no charge for an availability set. It's always free. You're only paying for the resources that get put in that availability set. So in our example, let's go with the 3 fault domains and 4 update domains. So with 3 fault domains and 4 update domains. Okay. So now essentially what I've got is a 3x4 12 thing here. Okay. So now the interesting thing is you selected the availability set, but unlike an availability zone, you can't pick the placement in an availability set. So this VMs, the placement is done by the Azure resource provider. You can't say I want VM1 in fault domain 0 and update domain 0. You can't say I want VM3 in this specific fault domain and update domain. The placement is actually decided by the resource provider, the compute resource provider in this case. And the way it goes is it places the first machine in fault domain 0, update domain 0. Then it increments for the next machine, it goes in fault domain 1, update domain 1. And for VM, the third VM, fault domain 2, update domain 2. Right. So now we've come to the upper ceiling of the fault domain. So now we go back to the previous fault domain. So while we go to the next update domain. So the next VM that comes in, obviously there's no fault domain 3. So it goes into fault domain 0, but the update domain increments. So your fourth VM gets placed here. Fifth VM is in the next fault domain and next update domain. At this point, you've hit the upper ceiling of the update domain. So the next update domain is update domain 0. So, and the next fault domain is FD2. So the next VM that you place, VM 6, gets put in the update domain 0 and fault domain 2. So this is how it ensures that your virtual machines, they are not sharing your fault and update domain. If you have any questions, feel free to type it in the chat window. I'll be taking a look in a few minutes. But that's how the general placement of machine works. You don't get to pick exactly where you want to place the machine. You let the resource provider place it for you. Again, this is paired with a load balancer. So you put a load balancer in front of all these redundancies, and the load balancer uses its health probe to check the health of the machine, and whichever healthy instances are there, they are available to serve the traffic. Right. So no two VMs share the same fault and update domain. Availability sets are free. You only paying for the VMs within the availability set. And similar to availability zone, this is a creation time decision. So once you've created the VM in an availability set, you can't move it. Okay. And similar to zones, the VMs in availability set need not be identical. You can have VM1 as your primary, which can be a slightly larger machine than VM2. Okay, if we compare and contrast, if you want redundancies within a region, you go with availability zones. If you want just within a data center, you go with availability set. This obviously means availability set has lower SLA while zones have higher SLA because they are spread out across multiple data centers in a region, while here it's within a data center. The placement, you get to pick the availability zone that you want to place your resources in, while this is controlled by the resource provider. Bunch of things that you can put in availability sets and availability zones. All regions have availability set. Most regions have availability zones, but some don't. Okay. There are some restrictions, like if you're using a load balancer, then all the resources must be tethered to the same virtual network. So if you're using availability zones or availability set with a load balancer, then all the VMs must be connected to the same virtual network. If you're using zonal VMs, if your virtual machine is in a specific zone, you can't use unmanaged disks. And if you're using managed disks, then it has to be from the same region. Here, there's a limitation that availability set, you have to place all the VMs in the same resource group and location for obvious reasons, because availability set only within a data center which is within a region. So it has that, but there's a further restriction that it has to be within the same resource group and they must be associated with the same VNet. I think we can skip this slide, but high level, use managed disks when you can. So when you pair managed disks with availability set, if you use aligned availability set, then your managed disks are placed on different storage clusters. So even if one storage cluster goes down, only that VM is affected, the other ones still keep running. However, if you use the classic availability set, then everything is in the same storage cluster. So if the storage cluster, one storage cluster goes down, although the compute is available, the storage becomes unavailable. So, if you need higher redundancy, higher SLA, go with managed or aligned availability sets. Okay. All right. Let's see where we are. Okay. Now let's talk about storage accounts. So storage accounts, as you're familiar, we use it for a couple of basically to store unstructured data. So anything, so blobs, You also have table storage and queue storage in there. And you have file storage as well, or file servers. But the majority of the use case is for storing unstructured data blobs. So let's look at how this thing works. How does, while using storage account to store blobs, how can you guarantee high availability? So if you're familiar with this, every storage account has a bunch of options, high availability options. So the least highly available is called LRS, which means locally redundant storage. So this is the one with the least SLA. Then you have zone redundant storage, where you are going to store copies across zones, availability zones. Then you have geo redundant, which means your copies are going to get stored across geographies. And then there is another special flavor of this. It's called read accessible GRS, and we'll look at it in a couple of seconds. But again, this is a decision that you generally make during creation of the storage account. When you create the storage account, you get to select the redundancy option. Okay, so look, whether you want it locally redundant, whether you want zone redundant, um, geo redundant, which means across multiple regions, or geo zone redundant. We'll get into that later. But let's look at this. So what happens in the LRS? So LRS is the cheapest available storage SKU. So you have 3 redundant copies that are created. So every time you upload a blob, 3 copies are created, but all 3 copies are within the same data center. So if the data center goes down, all 3 copies become unavailable. Zone redundant, you have 3 copies, but the 3 copies are spread across 3 different zones within a region. So the chances of all 3 copies being down at the same time are very, very rare. So this has higher SLAs. Geo redundant, again, 3, so this one has 6 copies. So in geo redundant, you have a primary and a secondary region. So primary has 3 copies and secondary has 3 copies. So primary can be West US and secondary will be East US too. And 3 copies in each region, so totally 6 copies. RAGRS, again, 6 copies, same concept. So every time you write a blob or update a blob or create a blob, the write commit happens to all 3 replicas, which means when you upload a blob, we write 3 copies, create 3 redundancies, only then we return back. The replication latency is very low because it's within a data center, right? All 3 copies are residing within a storage cluster in a data center, so low latency. Zone redundant has slightly higher write latencies because it has to write to 3 redundancies which are spread across 3 different availability zones. So slightly higher than the latency is slightly higher, but not much noticeable. Okay. For geo redundant, what happens is when you do a write commit, it writes to all 3 copies in the primary region and then returns. And then asynchronously, we start a copy from the primary to the secondary, and 3 copies are created again in the secondary in the background. So that's asynchronously done. Okay, so same as this thing in geo redundant, you get 3 as soon as you update a blob or create a blob, 3 copies get created in the primary, and the call returns. And in a background thread, the async replication to the secondary happens. Generally, the async replication finishes within a couple of milliseconds, but for SLA reasons, it says that there is a 15-minute RPO, recovery point objective. So which means it technically means that it may take up to 15 minutes, but generally takes a few seconds at the most. Okay. As you can see, LRS has the lowest SLA because all redundancies are within a data center. Here, it has a slightly higher SLA because redundancies are split across zones. GRS has obviously much higher, 16 nines, so that is 99.14 more nines. Okay. because they are spread across different regions in a geography. Endpoint. So LRS obviously has one endpoint. Although there are three redundancies, you can't access those, you can't address those three redundancies individually. You have to go through a common endpoint. And you can't pick which redundancy you want to write to. That part is taken care of by the service provider. Same with zone redundant, there's only a single endpoint. With geo redundant, although you have a primary and secondary, only the primary is accessible, the secondary is not accessible. However, with this special flavor called read accessible geo redundant storage, the primary is accessible and the secondary is accessible as a read only. So this is great for, so let's say your primary goes offline and you want to put your application in a read only mode where you can read from the secondary, but you don't want to write to the secondary. So this is awesome for those scenarios. And failover support, there is no secondary here, so no failovers, no secondary here, no failovers. For GRS and RAGRS, primaries and secondaries are available. So when a failover is initiated, the secondary becomes the new primary and the primary gets decommissioned. Okay. So just a quick, let's take a quick look at that one. So in our demo here, we have a demo for storage account demo. So this is a read accessible geo redundant storage. So here, if you go inside geo replication, you'll see that the primary region is East US, but there is a secondary being maintained in West US. So you can initiate user initiated failover, and what will happen in that case is the secondary becomes the new primary, and then the primary gets decommissioned. Which means now you have just one region, and so this becomes from a RAGRS to a LRS account. The secondary becomes a new LRS primary. Storage accounts. If you have any questions, please feel free to put it up in the chat window. We'll do a Q&A session at the end. All right. How are we doing for time? I think we're almost at the end, but let me also run through Traffic Manager real quickly. So like we looked at this graph here, availability sets, availability zones, they're great. You use a load balancer to route traffic to various instances across an availability zone or an availability set. So the span of the load balancer is a region, is within a region. However, if you have redundancy 1 in one region and redundancy 2 in a completely different region or a completely different geography, you can't use a you can't use a load balancer in that case. You will have to use a traffic manager. So this is an example. So in our previous example where we did the load balancer, they were in different availability zones, but in the same region. Everything was in East US2, both the virtual machine 1, the virtual machine 2, as well as the load balancer. So the load balancer cannot reach out to machines in some other region. It has to be within the same region. However, if we have machines in different regions, like in this example, traffic manager, so here we have VM3 and VM4. So VM3 is in East US and VM4 is in West Europe. So obviously they are in different geographies, not just different regions, but different geographies. So we can't use a load balancer at this point. So in this case, we have to go with something called as a traffic manager. So traffic manager works in similar ways. It routes traffic to different endpoints. So the endpoint are these two machines, VM3 and VM4. So let's take a quick look at that. So we have our VM3 and I'm going to load VM4 and I'm going to load the load balancer. Right, so I'm going to copy the IP address of VM3 here. It says, hey, welcome to VM3. Similarly, Copy the IP address of VM4. Okay. And they are in completely different regions. So this one is in East US, this one is in West Europe. So can't use a load balancer, I have to use a traffic manager. So traffic manager, it doesn't just have a IP address, it has a DNS endpoint as well. So I can just load that up and hit it. And it takes me to one of those two instances. Now, if I come back to VM, so now it's serving me from VM4. So now if I go back to VM4 and turn it off, okay, give it a couple of seconds. And here, if I refresh this, it should go back to VM3 now, this traffic manager. Takes a couple of seconds. So it's the health probe is actually checking whether the instances are healthy or not. But once the VM4 goes completely offline, this will start serving VM3 traffic. Okay, so now it has gone offline. So all we have to do is just keep trying it again until we hit VM3. So this is, I think, serving me cache data. Now I'm going to disable the cache data. In a couple of seconds, VM3 will become available. So the interesting thing there to remember here is the routing algorithm that you select. There are a couple of them available in the traffic manager profile. So if you go into the configuration, so there is something called as performance based, which means the stuff that has the instance that has the lowest latency, that's the one that's going to get served out to you. You can do weighted, which means you can assign weights. So this is generally used for blue-green deployments. So you can assign a 80-20 weight, and essentially what it means is 80% will be served out from instance 1 and 20% from instance 2. So priority is for warm, cold standby. So if you have a warm standby, which you always want to have it serve traffic, give it a higher priority number. If that one becomes available, then it sort of falls over to the next priority level. And geographic routing is, when you have compliance requirements, which says that you have to serve traffic out of the same region as which the request originated, at that point use the geographic routing. So let's take a look. So now I think by now it should have, this is bizarre. Not sure what happened there, but it's supposed to know that VM4 is offline. It's supposed to serve me traffic from VM3. Okay, not sure what's going wrong there. Okay. Oops. How do I get? So this called performance-based routing, and so VM3 is online. VM4 has been stopped. Yeah, now it goes to VM3. The traffic manager will now serve it from VM3. So again, the health probe, I think I'll have to check it more frequently than the current interval. So it takes a couple of seconds for it to switch over to the other healthy instance. So think of it as a load balancer, but not at regional level, but across multiple regions or multiple geographies. Which, by the way, brings me to this document, Azure Load Balancer Options. There is a nice algorithm which talks about various load balancing options. So I'll put this in the show notes again. But essentially, if you're confused about whether to choose a load balancer or a traffic manager or an application gateway or front door, there's a sort of algorithm which walks you through it. But at a high level, if you need to do things at layer 7, which is HTTP or HTTPS level, you need to do things like URL rewriting or URL routing, or you need firewalls. At that point, layer 7 stuff would be your application gateway. If you just need to deal with TCP traffic and port 80, port 443, at that point you can just use a load balancer. So load balancer will not give you firewall rules. It won't give you host names. It won't give you things like SSL offload and all that. It's just for like raw IP addresses. Load balancer works fine and works within a region. Traffic manager, same as load balancer, but works across regions. Application gateway is like a load balancer, but has firewalls, SSL offload capabilities, URL rewriting capabilities, and a bunch of that. So if you're just serving something like databases, do it with a load balancer. But if you need to run a website with a TLS offload, use application gateway. Application gateway again works in a very similar fashion. So I have a demo for that as well. So you have application gateway here. So you have two web apps, App Service 1 and App Service 2. And this is my App Service 1. And similarly, I have App Service 2. Now, both of them are in the same region. I'm going to put instead of putting a load balancer there, I'm going to put an application gateway. So here's my application gateway. It's similar to a load balancer, but with additional HTTP capabilities, right? So SSL offloads, you want to do that, you can do it here. Firewalls, you can do that. But you can't do firewalls and SSL offload with load balancers. So here, all we do is we will copy the IP address here. And so this is App Service 1, App Service 2, and this is our application gateway. Okay, so it's serving from App Service 1. So we'll go ahead and disable App Service 1. Okay. And we'll let the health probe check whether App Service 1 is unhealthy. And if you keep refreshing it enough times, you will notice that it will switch over from App Service 1 to App Service 2. Okay, there we go. So now you will never bring up App Service 1 again. Okay. So that's application gateway, like a load balancer, but with firewall capabilities, TLS offload. And similarly, it's not a layer 4 solution. It doesn't operate at TCP level. It operates at HTTP and HTTPS level. All right, where were we? So availability zones and traffic manager we talked about. Final thing I want to talk about is SQL Azure. So SQL Azure high availability options. Go to the demo there. So SQL option has two things. So there is high availability options available at the server level or at the database level. So SQL Server can contain multiple SQL databases. So there's a one-to-many thing. So if you want to do it at database level, high availability options, so you use a feature called geo-replication. If you do it at the server level, you have auto failover groups. Okay. So whether you want redundancy at server level, for all the DBs in that server, use failover groups. If not, go with geo-replication. Okay. So geo-replication is pretty straightforward. Okay, so I have server 1 in East US and server 2 in Southeast Asia. Similarly, database 1 is on server 1 in East US and database this thing is on server 2. So the way this is done is I go in, so this is my primary. This is my read writable primary, and I come into replicas. Okay? And I just say create a replica, and the replica cannot be in the same region. It has to be in a different region. So which is what geo replica means. You spread it across geographies or regions. And then it asks you to pick a server where you want to place it. Okay. So that way I have my primary, which is demo DB1. That's in East US. And it's replica, which is also called demo DB1, but it's on a different server in a different region. And if I need to fail over from the primary to secondary, all I have to do is say forced failover. There is no automated or a planned failovers possible in a geo replica. If you want to do that, you have to go to active, do it at the server level. So I can just now say forced failover, and now it will switch over the primaries and the secondaries. So the primary becomes a secondary and secondary becomes a primary. So let's quickly walk through that. So you can have up to 4 readable secondaries, and there is asynchronous replication between them, which means you write to the primary and there is eventual consistency between them. So they will eventually catch up with the primary. So there is a possibility that you may be reading stale data, and your application has to be okay with that. Okay. Primaries and secondaries have to be in the same pricing tier, which means if you use a general purpose thing here, you can't use a business critical as a secondary. Or if you're using a business critical SKU here, you can't use a general purpose SKU here. So the failover, the way it works is secondary is promoted to primary. There's immediate failover. It doesn't wait for the replication to fully flush out. Old primary becomes secondary, and secondary becomes the secondary becomes the primary, and primary becomes the secondary. So that is active geo replication. So replication at database level. Now you want to talk about application at server level. Server may have multiple databases. If you want to replicate all of them, you do it at the server level with the auto failover group. So the way to do that is in your, again, I have a server in East US and another server in Southeast Asia. So I go into my primary server and I go to failover groups and I say add a failover group. So it allows me to create a failover group in a different region though. Okay, you have to create it in a different region, and whatever databases are there on that server, they will get replicated over onto the secondary region. So now we come to this failover group, and I can see that my primary is in East US and secondary is in Southeast Asia. So I can now initiate a failover, or I can initiate a forced failover. Forced failover means it doesn't wait for replication to flush out. If it's unreplicated, it just fails over. Regular failover will wait for the data to get flushed out, and then it fails over. So this is how we swap the primaries and secondaries in case of an outage. We do the failovers. All right, so that was SQL, and I think this is all the demos that I had. Traffic manager, storage account, SQL demos, load balancer, app gateway, and final thing is CDN. So if you're serving static data instead of serving out like if you don't need a web service, or if you're just serving out some JavaScript that can execute in a browser, you can you can serve it out of a storage account. So in your storage account, all you have to do is go to static website and enable static site hosting. Okay, so it's disabled by default. You can just enable it, and now you get an endpoint. So you can push your application in that storage account, and it'll, so this is an example of a simple Hello World Blazor app, so that I'm serving out of a storage account. Now there is only one global instance here, and it's all static content, right? This is all JavaScript or WASM files that are served to the browser. So why not use a CDN in front of it? So when you put a CDN in front of it, it creates regional point of presence server. So your data is cached in a nearby region. So if you tether this to a CDN account, CDN profile, you will be served the same set of files, but from a server that is nearby to you. So to do that, all you have to do is you have to create a CDN profile. Okay, so CDN profiles are global. It doesn't have any regional, it's not region specific. And then you create an endpoint which points to that storage account. So all you have to give it some name, something, and you select origin type as static storage, static site hosting, and then you select the storage account. And that's it. So now the same thing that is available from the, so this is being served out of a blob storage. Right? So if I need to make that same thing available from the CDN, all I have to do is go to the CDN endpoint. And the CDN endpoint will also have a URL. Right? And this will serve me the cached copy. Right? So it will load up a little bit faster. So this is from the storage account directly. This is from the CDN. So CDN also does other things like you can have like compression, caching. You can do managed TLS certs. All those things are possible. You can have like HTTP rewriting rules. So for redirecting from HTTP to HTTPS, all those things are possible with the CDN. So front door, a service called front door is nothing but CDN on steroids. So CDN plus firewall plus some application gateway functionality, all of that is known as the front door. So again, this operates at a global level. So location, if you can see, it's global. It's not tethered to one specific region. So there are point of presence servers present in every region. So you are going to run a cached copy locally. So the latency is also very low. All right. And with that, I think we come to the end of the presentation. I'm sorry I went a couple of minutes over, but at this point, if there are any questions, I can definitely be happy to answer them. So with that, let's open up the floor for questions. Let me just check the thing, see if we have any questions. Okay, so one question is, can you ping me that load balancer diagram link? Yes, so let me copy that in the chat window itself. That way, and we'll be sharing this in the meetup link after the presentation is done. But here you go. Are there other questions? Okay, so once storage account is created, can we change LRS or ZRS? Yes, you can. So once you have created a storage account, you can always upgrade or downgrade it later. So in this example, this one is I believe this is a locally redundant. This is a LRS storage here. So I can just go into the configuration somewhere and change it. Let's see where it is at configuration. And I can promote it from locally redundant to geo redundant. Okay, so those things are possible. So the reason it doesn't show a ZRS here, the zone redundant, is probably this region where it is created doesn't support a availability zone. All right, let's jump to the next question. How the cost will be calculated for this high availability? Again, you're not all the high availability constructs like traffic. So like if you are using an availability set, the set itself is free. You're only paying for the VMs that you place in the set. If you put it in availability zones, the zones don't have any charges. You're only paying for the VMs or resources that you play in the zones. However, with Traffic Manager, which you use for intra-regional routing, Traffic Manager has some charges. So you can look up Traffic Manager pricing in the pricing calculator. Okay, and generally, use the Azure pricing calculator as a good, it gives a good idea about what your end deployment will end up looking like. So if you put in, let's say, Traffic Manager, so shows you, how many units you are serving out, how many this thing you're sending, and generally, it'll compute the entire cost. So I think like the minimum thing, even if you are creating it but not using it, I think you end up paying like $50 for traffic manager. However, no such cost for availability set and availability zones. You're only paying for the virtual machines. With traffic manager, you're paying for the virtual machines as well as the traffic manager itself. The traffic manager has costs. Your load balancer is, I believe, free, if I'm not mistaken. Yeah, so load balancer is free of charge. You're paying for the virtual machines which are behind the load balancer. Then you come to application gateway. So application gateway has some charges, like for the gateway hours for the time it is up, because it does things like TLS offload and stuff like that. So there are charges. So like let's say you keep it up, you have one instance running. So at a minimum, it's going to cost you $18 a month, right? And that doesn't account for ingress and egress. So those are the thing, and CDN obviously has charges because it's caching your data, so you have to pay for the cache data. So here's your CDN. So let's say you have using the Microsoft standard one, and it depends on like how many zones you host it in and all that. So there are like a couple of charges there, but it's negligible generally. Front door obviously is sort of like CDN with firewall and all that, so a little more expensive. So I hope that answers the question. I know I'm sort of like rushing through it, but pricing calculator is again your best bet. Where VM7 will come, I have no idea what VM7 is. No idea what the question is. Okay. All right.
No, we got the fault of high.
I'm sorry, can you repeat that again?
Yeah, we have the fault domain and update domain, right? In that
Yeah.
diagram, we have the VM till 6. So if
Oh,
we
yeah,
want
yeah.
to align the VM7, then in which place that will come like that?
No, the you can't create the VM. So I know what you're talking about. So let me bring up that slide. This one, right? So here, so this one will take a max of 6 VMs only. So when you try to create a 7th VM with that availability set, the provisioning itself will fail. VM7 cannot be created with 3 fault domains and 4 update domains, because although this is a 3 by so this is 3 by 5, although this has 15 slots, the minute you start packing more things in there, it will see, the goal here is to make sure that you are not sharing a common fault or update domain, right? You can share one of the two, but you can't share both of them. So for example, VM1 and VM6, they share an update domain, but they are in different fault domains. So actually, now that you mention it, it is completely possible that, yeah, you can actually pack VM7. So VM7 will go into, if I am not mistaken, so you have hit the upper ceiling here of FD2. So it's going to go back to FD0 and FD0 and UD1. So VM7 will get placed here, if I'm not mistaken. But again, that sort of like defeats the whole purpose of using an availability set. Don't do these things. Actually, during the availability set creation, you have the option of specifying the number of fault domains and number of update domains. So at that point, just maximize the number of fault and update domains. Remember, availability set is free of charge. So just use the maximum number of this thing. So when you go back to creating the virtual machine, so let's say I go and create a VM. Maybe in this resource group. And let's say I create a VM here. And I say availability set, create new. So instead of packing too many VMs in availability set, just maximize this. This doesn't have any cost, right? So just maximize this. Create as many fault domains and update domains as you want, and then start packing your VMs inside it. Don't create, like a small limited number. You're not paying for availability set, so just just go crazy on it. I hope that answers your question.
Yeah, thanks. Yeah.
All right. Can you please display the auto failover for SQL Server side again? So, Jyoti, this is a question from Jyoti. So, do you want to do it? So, are you talking about auto failover groups or the geo replication? So, I think since you're talking about server, I think you mean auto failover group. So, let me demonstrate that. So, if we go to our auto failover group here, resource groups, and we go to auto failover. So I have a primary in East US and secondary in Southeast Asia. So I'm going to go to my primary server and I'm going to look up my failover groups. Okay. And this is the failover group. So here's my primary and here's my secondary. If I just need to swap, I'll just do a failover and say yes. So it takes a couple of minutes for the swap to happen. It first waits for since this is a sort of like a manual failover, it's not a forced failover. So it'll wait for the data to sync and then it will fail over. So it takes a couple of minutes, but after that, you will see that the primary and secondary have been swapped. Right? So we'll just give it a couple of minutes. So in the meanwhile, let me look up more questions. All right. Can you please? I think that we've run towards the end of the question. If there are any more questions? Okay, can the load balancer be automated based on traffic? Can you elaborate a little bit on what exactly means? So I'll show you how the load balancer works. Okay, by the way, here you go. The failover succeeded, and now you see that the primary and secondary have been switched now. Okay, so this now here is your Southeast Asia is now your primary, and your secondary is now in East US. So that's the failover process. Okay, load balancer, load balancing rules. Where we go? All right, so here is the load balancer. So load balancer, actually I had a slide which so high level, the way it works. Okay. There is a front end configuration, which means there is a front end IP address here, and there is a back end pool. Now the pool might be a couple of machines split across availability sets or split across availability zones, doesn't matter. And there is a health probe, which is querying the machines every 5 seconds, and if it receives it doesn't receive two responses in a row, it considers the machine as unhealthy. And then there is a load balancing rule which sort of like ties all of them together. Okay, so that is this rule which says, hey, if something is coming on port 80 from any IP address directed to port 80 on that specific IP address. Take a look what that looks like. So here's our load balancer. So front end configuration means here's the IP address of the load balancer, the backend pool of the load balancer, the two virtual machines that are being used. And there is a health probe which says, hey, every 5 seconds, send some traffic on port 80. And if you get two no replies in a row, consider the machine as unhealthy. And then you have load balancing rules. This one. So rule is sort of the thing that ties it together. So rule says that here's the front end IP I want to use. Here's the backend backend pool I want to use. Here's the probe I want to use. And now, if something comes at port 80, don't redirect it to some other port. Use port 80 from the backend itself. And you can also do things like session stickiness. So if your client, you can affinitize your client to stick to one of the servers. So for the duration of that session, it will only get served traffic from that specific server. That session persistence can be based on just the client IP or the client IP and protocol, which is HTTP and HTTPS. So a couple other things are possible. I've never used any of these settings, so I'm not too familiar with them. But the high level, the rule is this, which ties the front end configuration to the backend pool with a probe and session persistence. That is like the only sort of rules that are possible at the load balancer level. Okay. New messages. Okay, couple more questions. Thank you. Can you explain inbound and out? Okay, Jyoti, I do not know enough about networking details to explain what an inbound NAT rule is. Sorry, I mean it's outside the realm of my knowledge. I've only ever used it with like regular serving regular traffic. So inbound and outbound rules, I have no idea what they are. All right. All right, if there are no other questions, I think we can conclude the session. So I'll put this slide up, and actually it is already available on SlideShare. I'll post the link. So SlideShare. The slides, I've put it up. And once again, I am available on Twitter. So if you have any questions at any, just feel free to DM. My DMs are open there. So if you have any questions on this, on any of the load balancers, traffic managers, availability zone set, doesn't matter what. If you have any questions, feel free to ping me. So I'm available. So my just a second, yeah. So these are my. So that's my blog. Oops. So that's my blog and that's my Twitter handle. So I'm pretty active on Twitter. So if you need to reach out to me, feel free to do so. With that, thank you everyone. We've gone way over time, but I thanks everyone for being here today, taking time out today evening. And I hope to see you all. I hope everybody got something useful out of this session, and I hope to see you all again in a future session. So with that, thank you very much. Over to you, Rashmita.
Thank you so much, Mithun, for this lovely session, and thank you all for joining us today. Please do the event check-in and do share your feedback about today's session. It will help us to choose our topics better. Also, please visit Microsoft Reactor Bengaluru meetup page for more upcoming session. Thank you all once again and enjoy the rest of your day.